we are going to go over a few notes just to reiterate what we talked about previously about parallel and perpendicular slopes, and then you will practice this and turn this in. So parallel lines are lines that never intersect. Remember, they stay equidistant from each other the whole time. So algebraically, how do we know if two lines are parallel? They have the same slope. So if I was to give you an example, so y equals 2x plus 1 and y equals 2x minus 7, I know without graphing that these are parallel because they both have a slope of positive 2. Perpendicular lines are lines that intersect at 90-degree angles. So they form a right angle. And algebraically, how do we know that? They have opposite reciprocal slopes. And I wrote in 2 lines because I'm going to give you another example. So if I have y equals 2x plus 3, opposite means if one is positive, the second one has to be negative. So if this is a positive 2, I need to make this a negative slope for the second line. Okay, and then this is going to be a 1/2, a 1 over 2, because 2 is basically being divided by 1. We just don't write all whole numbers being divided by 1, but 2 is being divided by 1 right now. Okay, so these slopes right here are perpendicular because one's positive, one's negative, and they're opposite of each other. And if it helps you on your paper, you could draw a little 1 under here to show that they flipped. And if you're wondering where I got these from, I just made them up. Okay, I made up the +3, I made up the +5, things like that. So let's look at some examples here of opposite reciprocals because this is the hardest concept to grasp. Parallel is easy because they're exactly the same, but sometimes we accidentally make mistakes with perpendicular. So opposite, this is a positive, my new one has to be negative. And I'm going to flip the fractions. So 4 needs to come up top in the numerator, 3 needs to go in the denominator. Okay, I'm going to go make this a fraction, so that helps me right away. If this is a positive 2, opposite, this one has to be negative, and then reciprocal, flip the fractions. So 1's on the top, 2's on the bottom. Go ahead and try question 3 on your own. This one is a -7/8. The new one has to be positive. 8 comes upstairs, 7 moves downstairs. If this is a positive 1, the new slope would have to be a negative and 1 over 1. So this would also be 1 over 1, which that could just reduce to just a negative 1. So you can write it whatever makes sense to you. Question 5, I am going to draw you a picture of a 0 slope. So remember, Mr. Slope Dude, this is 0 fun. So here's a slope of 0. If I need to be perpendicular to that for question 5, it would go directly through it like this. Well, remember when he was falling off the cliff? What kind of slope was that? Undefined. Remember when he was yelling that? So the slope here for question 5 would be undefined. Hopefully that picture kind of helps. Okay, we also could draw, if I was to slide all of this over, we also could draw a picture for question 4, because if I had a slope of positive 1, it looks like this, just going up 1 over 1 every time. Slope of a negative 1 looks like this, so they're going to intersect at 90 degrees. Positive 1 over 1, negative 1 over 1. Okay, so here's what you need to do for the rest of the worksheet. For questions 1 through 6, similar to what we did in the book, you're going to look at these and tell me, are they parallel? Are they perpendicular? Or are they neither? Okay, parallel is exactly the same. Perpendicular has opposite signs, and reciprocals, meaning you're flipping the fraction. Okay, and then questions 7a, just tell me the slope parallel. 7b, tell me the slope perpendicular. Same thing for 8. Tell me the slope parallel, tell me the slope perpendicular. You can do it, and if you need help, the agenda says join my Zoom call, or you can shoot me a Schoology message or an email. Good luck, do your best. You can do it because you're all smart and you're all rock stars.